Alright, so this is going to be a quick tutorial about ionic bonding. Okay, the lesson objectives will be to explain what ionic bonding is, to explain how an ionic compound forms, and to explain how to name ionic compounds. Alright, so what is ionic bonding? Well, based on its name, you can kind of guess. It's the bonding that happens between ions. And the ions have to have opposite charge because if you remember, opposites attract and bonding involves things coming together. So because of that, it's the bonding among ions of opposite charge. Okay, at least one ion must be positive and at least one ion must be negative in order for it to happen. Now, which types of atoms can have a positive charge? If you remember from the last video and the previous unit, metals form cations, which cations is a positive ion. So we have metals, and the negative charge is going to be the nonmetals, and it's going to form anions. Okay, so ionic bonding involves metal and nonmetal ions. You have to have metal and nonmetal ions to have an ionic bond. So I'm going to walk you through a brief ionic bonding example to kind of show you how ionic bonding works. So what I want you to do first is draw sodium, Na, and Cl, which is chlorine. I want you to draw Lewis symbols for both of those. Pause the video right now. I'll give you as much time as you need. When you're ready, just hit play again. Alright, so let's see what you got for your Lewis symbols for Na and Cl. So Na is going to have one valence electron, so I'm going to put one dot on the outside of it. And it's going to look like this in real life. It's a metal. As you know, it's an alkali metal, and that's what it looks like. And then we have chlorine, which has 7 valence electrons, and it's actually a gas as an element. So this is what they look like in real life. And what's going to happen between these two elements, basically, is that if you remember from the last unit with periodic trends, electronegativity, chlorine is more electronegative than sodium. So if you put these close enough together, what's going to end up happening is this chlorine is going to be pulling one of these electrons from the sodium because it's more attractive. It's got more protons than the sodium, and so because of that, it's going to be pulling the sodium a little bit more. If you remember, they're both in the same period, so based on how trends work, chlorine will be more electronegatives. So this electron in sodium is going to leave the sodium element and form that octet. So chlorine will now have 8 electrons and be more stable. And then sodium will also have 8 electrons in its outer shell and be more stable. So then what you end up forming is the sodium loses an electron and then it has a positive charge. So now you formed our cation, our positively charged ion, sodium, and our negatively charged ion, which is an anion of chlorine right here. Now, this positive and this negative are going to attract each other because opposites attract. Then what happens when these attract each other, they form an ionic compound of NaCl, which is basically just table salt, something that we ingest every single day. So that's basically the basics of how ionic bonding works. One of the electrons gets taken from the least electronegative, which is going to be a metal every time. And because of that, it's going to give the anion, or it's going to give the nonmetal a negative charge to form an anion, and then the metal becomes a cation. The positives and negatives attract each other to form an ionic compound, NaCl. Okay, here's the actual reaction between sodium and chlorine taking place. It's a little video. I'll give you the play-by-play. So basically what the scientist is doing is taking some sodium and putting it in this little spoon right here and then heating it up just to kind of get the reaction going. So once it's heated up a little bit, they're going to put it in this container right here that has a bunch of chlorine gas in it. I showed you a picture before. And what ends up happening is that this sodium ends up reacting with the chlorine. And as it's reacting, it's releasing energy in the form of heat and light, and I'm sure some sound. And this bright white light gets formed on it as the reaction is taking place. And this is going to happen until the sodium completely reacts with the chlorine. As you can see right here, we end up having our final product, which is that salt. So that's that white powder in there ends up being table salt. Okay, so ionic compounds. When ions bond, ionic compounds are created. Okay, and here is the basic rules of how to name ionic compounds. What you do, you always put the metal first, and then the nonmetal comes afterwards. Except the difference is, instead of having the whole nonmetal name, you replace the suffix, whatever it ends with an "ide." Okay, so if the suffix is "on," like in boron, or ogen, like nitrogen, or aris, like phosphorus, or igen, like oxygen, or sulfur, or any of the ioms or the chlorine, fluorine, that sort of thing, you replace it with an "ide." Okay, and I'm going to show you an example to kind of have this make more sense. Okay, if you were naming binary ionic compounds containing a metal ion with variable charge, which we're going to go over later on in the unit, what this time you do is you put the metal and then you kind of put it in the chart. You put the charge as a Roman numeral this time, plus the same non-metal ion. But we're going to go over that later. Let's look at the examples for this first one right here. All right, so we have the metal plus the non-metal only as an ide. Okay, so we have sodium and chlorine. Sodium and chlorine. So you just put the metal name sodium down, and then instead of chlorine, you do chloride. So it'd be sodium chloride, as simple as that. Next one, you have magnesium and fluorine. Now there's two fluorines, but that's okay. So we have magnesium, you would write the word magnesium down, and then instead of fluorine, you would write fluoride. So magnesium fluoride. Next one, we have aluminum and carbon. So we would have aluminum carbide. And then lastly, we have calcium and phosphorus, so it would be calcium phosphide. Okay, so that's basic naming of ionic compounds and the basics behind ionic bonding. If you have any questions about anything in this video, let me know.